Welcome to Machine Learning Part 2. My name is Richard Kirshner with the Simplilearn team. That's www.simplilearn.com. Get certified, get ahead. And today we're going to cover the random forest in R. If you remember from Part 1, we did the decision tree. And no one wants a poor lone standing tree out in the field. We want a forest. And so we're going to cover random forest. Just a little play on words there. I'm sure the people who designed it also knew that too when they were thinking about it. So what's in it for you? What is a random forest? How does a random forest work? We're going to cover applications of a random forest, some of the terms you need to know when using a random forest, and then we'll go over the use case in R, predicting the quality of wine. So let's start a little bit with exploring what is a random forest. And welcome to Raphael's vineyard in, I don't even know how to pronounce that, in Alsace, France, the largest wine production region in the world. So they have centuries of wine production and data they've collected on how to make their grapes and grow them and how to properly get the right grapes and ferment them. Like Raphael, winemakers around the world are facing a grave problem. So let's meet the man himself and try helping him out. What is a random forest? We're going to come back to the vineyard, but we're going to look at some other examples along the way too. Open up the door, and of course here comes Raphael. I'd probably look closer to Raphael than I do to the young lad with the beard. Hey Raphael, so tell us how it's going. Not as good as before. Not many people work in this profession anymore, so every stage of production has gone slower. If only we could somehow speed up the process. Well, lucky for you, I'm a machine learning engineer. How about we automate the quality prediction process for wine? Let me begin by telling you what machine learning and random forest is. Machine learning is the science of applying algorithms that allow a computer to predict the outcome without being explicitly programmed. Random forest is an ensemble machine learning algorithm. So we're bringing in different pieces and then putting those pieces together. It operates by building multiple decision trees. Remember I told you we don't want just a lone tree out there, we want a forest? They work for both classification. If you remember from Part 1, we had our vendor with his broccoli and oranges. I think he also had carrots. And it also, the output given by the majority of its decision trees is the forest final output. So if you have a number of decision trees, you have 5 decision trees and 4 of them say it's broccoli, then it's probably broccoli. And you can also use it as a regression model. The output given by the majority of decision trees is a forest final output, just like you do in classification. You can also come up with actual values and numbers as a regression model. Could you explain how a random forest works in layman terms? It's always a good thing to explore the information on something a little bit easier to understand and see. Sure, let's consider the case of Sam, a high school student. This so reminds me of my own high school student who's just started his first year in college, asking all his friends. So Sam is confused on which course to take up. So he's trying to figure out what his next class is going to be at school. Should he take music lessons, dance lessons, math, science, maybe social studies? So he decides to ask a couple of his friends for suggestions. And Sam approaches Jane first. So he comes up to Jane and says, hey, which of these classes should I take? And Jane asks Sam a few questions based on which she can suggest. Theoretical? Do you like theory? No, he doesn't like the theory part. Calculative? Do you like calculative? And he goes, yes, I like doing calculations. And so Jane, based on a couple questions, she has her little decision tree there going. She goes, mathematics sounds good. So Jane forms a decision tree based on Sam's response and gives her suggestion. And of course, this is based on Jane's views and her history and the data that she's collected over her years in high school. Next, Sam approaches Bella. Bella asks him, hey, do you like the field of science? And Sam goes, yes. And then Bella goes, do you like new in industry? You like new things coming up in industry? And Sam goes, yes. And Bella goes, you should, similar to Jane, Bella also forms a decision tree based on Sam's response and gives her suggestion and says, hey, how about artificial intelligence? Sam's like, oh, artificial intelligence. So Sam next asks Terry for his suggestion, and Sam goes, do you like scoring things? And he goes, yes. And he goes, do you like theoretical? And he goes, no. And he comes up and says, mathematics. So you have 2 people saying mathematics and 1 person suggesting artificial intelligence. Since 2 out of 3 friends suggested math, Sam decides to take mathematics. And there's a lot of subtleties in this example. It's actually a really good example. Some of the things we run into in data science is when we collect data, and we collect from different sources, we might have data from one source that measures one thing or or one set of instruments. And we might have data from another source that measures something else. We saw that with each of his friends are measuring different things and asking different questions. That's a little bit beyond the scope of this particular tutorial. So let's go back to our wine cellar. So you see, more the number of decision trees, more accurate will be the prediction. Random forests have a number of applications in market already. If you've been watching any of our other tutorials, you'll see that these are very common. We have in banking, it can be used to predict fraudulent customers. It is used to analyze symptoms of patients and detecting the disease. In e-commerce, the recommendations are predicted based on customers' activity. Stock market trends can be analyzed to predict profit or loss. Most recently, I was watching a review on weather here in the United States and the data they pull in for that. And one of the top weather places actually uses 5 different models. Random Forest was one of them, I believe. They use 5 different models to predict the weather, and depending on what the models come up with and what's going on, some of the models do better than others. I thought that was really interesting. It's important to note. So when you see us repeat the same things over and over, and you're looking at the different machine learning tools, you realize that we use multiple tools to solve the same problem, and we can find the best one that fits for that particular situation. So let's see how that fits back in our wine production. To help speed up the process of wine production, we will automate the prediction of wine quality. Suppose our random forest builds 3 decision trees. We have the first decision tree, which is going to divide everything by chlorides, less than 0.08, and it's either yes or no, and then it's going to look at alcohol greater than 6, yes or no, quality equals high, quality not so good, and if the chlorides were greater than 0.08, quality equals low. So there's our first tree. And then our second tree is going to split it on sulfates less than 0.6, and pH less than 3.5. And again, we have it coming down here that if the pH is low and the sulfites are low, the quality equals high. If the pH is a little higher but the sulfites are low, it's not so good. And if the sulfides are greater than 0.6, we have a quality equal to low. And then we'll do a third decision tree. We'll split it based on pH. And we can see below how that tree looks like with our sugar less than 2.5. If not, it's a quality equals low. It's a real low quality. And if it is less than 2.5, then the pH decide whether it's going to be a quality high or not so good. And if we track one of our wines down the list, we'll look at it and we'll say, oh, 2 out of 3 decision trees indicate the quality of our wine to be high. The forest predicts the same. So this sounds promising. So let's go ahead and dive in and see what that actually looks like. So this is the data set that holds all the attribute values required to predict the wine's quality. And I'll pull this up in a spreadsheet in just a moment. But you can see here we have fixed acidity, volatile acidity, citric acid, all the way to quality. And then quality is like a 4, 5, 6, or 7, I believe. And this will be done in R. So let's go ahead and get started on our coding. We'll be using RStudio. Before we dive into RStudio, I always like to open up the data in the spreadsheet and look at the actual data that I have. And they've called it winequality-red.xls, so it's a spreadsheet, a Microsoft spreadsheet. And when we open it up, we'll see that it matches what we had before, as far as the slide was showing us. We have 12 different columns. The first 11 are our features, our fixed acidity, volatile acid, citric acid, things you always want to look at when you're looking at your data. And we've done this before in the part 1, but just a reminder, we want to note that we have decimal places here, float values in a lot of these things, especially the first number of columns. Our free sulfur dioxide looks to be an integer, but it varies a lot. So we have, I see some values all the way up to 51, 7, 4. So we'd probably keep this as a linear model kind of thing. Same thing with the sulfur dioxides, densities again, decimal places, sulfides, alcohol. Quality. I want you to note in the quality that we only have a few qualities here. This isn't like a spread between 0 and 100. It looks to be 3, 4, 5, 6, and 7. And so when we start looking at the process, we can have the option of either doing this as a series of integers or float values going from 3 to 7, or we can convert that to a categorical, 3, 4, 5, 6, and 7 being the categories. But we'll look at that in the coding here in just a minute. And finally, you'd want to go ahead and scroll down through the data and just look for missing data or anything weird. Obviously, working with big data, you wouldn't be able to do that if this was spread across numerous computers and you had millions of rows. We have, 1,687 rows here, so it's a nice size spreadsheet, still considered a small data set. Let's go ahead and switch over, and let's take a look at this in the R. So here we are in our R Studio, and if you remember, it comes up automatically in 3 panels. I have my font on fairly large to help out. The upper left panel is a file that's open. You can have multiple files and tabs open, as you can see on mine right now. I'll probably close most of those in just a minute. And this is where you can put in your commands. Then you can execute these commands by either clicking on the run box or Control-Enter is the hotkeys for that. And all that does is then puts that down in the console and executes that line of command. You could just paste these directly in the console. I've certainly been known to do that if I'm loading up some data and I just want to take a quick look at it in R because I'm doing the coding in something else. Or if I just want to do a quick explore before I dive in and figure out what needs to be done. That's one of the tricks you can do. And then on the right hand side we have our environment, history connections. We mainly are going to just be sitting on plots, and I'm just going to minimize this for right now out of the way while we dive in. If you haven't yet, you do need to go ahead and install the package Random Forest. I'm not actually going to do that because I've already run that. We don't need to rerun that. But I am going to go ahead and import it into our project with the library and then Random Forest. And we'll do the Control-Enter. You can always hit the Run button up there too. And then now the library has been uploaded in there, and you can see down below it takes this and just copies it and pastes it down below and runs it in our console. And then just a quick troubleshooting thing. My Java happens to be the developer's Java. The latest release of the developer's Java from last week is clashing with my R and rerouting my Java files. So chances are you don't need to look this up or find out where your Java is. But there's a JRE folder. If you do have an error that comes up in the next library, you look that up. It's usually under Program Files, Java, and you'll see JDK, depending on what version you have on there, and then find that JRE folder. And I'm just going to set the environment on there. You have to do that every time you run the script. So with R, there is a place in R where you can set it permanently, but generally it's set to whatever your system variables are set to, so you don't want to mess with that. So you just want to put this in your code if you're having problems, and you can always take it out. And then we need to go ahead and bring in another library, and we're going to be importing the spreadsheet, so it's the XLSX, since it's a Microsoft spreadsheet. And I'll go ahead and run that. Now let's go ahead and create a variable path. We're going to assign to variable path the location of our folder. So this is a very lengthy one. You'll have to copy and paste it off your computer. My name is Richard, and you can see it's under C column Users, Richard's Documents, Docs Business, Simplilearn, Marketing, Random Forest, and then the actual file, which is winequality-red.xls. So I put in the whole path in here. And you could also set the computer path to whatever folder you have it in, and then just use the name of the file. But I went ahead and did this because a lot of times it's good to be aware where your paths are going and where you're pulling your data from. And again, I went the Control-Enter, so you'll see that pushed the line down below and ran that line, so our path is now set. And then let's create a variable called data, and we'll assign that to a read. And we're going to be reading, let's see, where is it? There it is, on spreadsheet. And before I put in, we need the path, but we also need one more thing on the spreadsheet. Because it is an Excel spreadsheet, we need to know which page we're on. So let's go look that up. And in the spreadsheet, it might be a little hard to see because it's a very tiny font down there. But you'll see the page tabs on the bottom. This actually has 2 different pages. And we want page 1 for this project. So let's flip back over and put that in our code. And the term they use is sheet index. I always have to look that stuff up. And it was sheet index of 1. We'll go ahead and execute this. So at this point, we've now loaded the data into the variable data. And it's reading those in. I think there was a couple thousand rows of data in there, so it takes it just a moment to pull it in. Once I have my data in there, I always like to do something like this. Data, and I always forget in R it's head data, and we can run that, and you'll see it prints out what we looked at in the spreadsheet. So we have our fixed acidity, volatile acidity, citric acid, residual sugar, chlorides, free sulfur, all the different things. We're actually looking for quality, so you want to keep that in mind, that quality is the final setting. Is it a 3, 4, 5, 6? What is the quality on there? And the first thing we need to do is we're actually going to take the data quality, and let me see, quality, there it is. In R, the $ means that you're looking at one of the columns in here, or features as it is. So we see data $quality in R, that means that's what we're going to be editing. And what we want to do is we want to change the quality just a little bit. And so we're going to set it equal to. Now we're not assigning a variable, we're altering it. So data $quality equals, and we want to do as is one of the functions in R. And we're going to do as a factor. And then data quality, because that's what we're actually editing on there. And let's stop just for a second and look at this. Factor takes this and looks at the data as a categorically. So instead of it being on a continual scale of 0 to 100 or something like that, it actually looks at it as category of 5, category of 6, category of A, category of cat, category of dog. They're yes or no categories versus a continual. Now there's a lot of different things in here that we could do the same thing with, but all of these really are linear numbers, 7.4, 0.70, sulfur dioxide 3467. So we really don't need to mess with any of the other variables in there, but we do want to go ahead and set this up. And we'll come up here and we'll do our control enter, and it'll run it down below. And you'll see data quality equals as factor data quality. So we've now turned that into a factor, or into a categorical data. And so let me just bring this down a little bit. The guys in the back did the rest of this next piece of code. There are so many different ways, and if you have been looking at any of our tutorials, this should look kind of familiar. This is one way to do it. And you'll see we have our training data and our testing data. And so what we've done here is we have a data set size equals, and we're just going to do by the row. And so we want 0.8, or 80% of the data is going to be our training set to train our forest. And if you train a forest or any machine learning model, of course want to test it. So we're going to save 20% of the data for testing. And when you look at this, we have the index, which we set at 80%, comma, and then a negative index. So that's the remaining setup. So it goes from that index on. This is our notation for sorting out that data. And then we create the index, and we use the term sample. And this is just going to go in there and set our different samples for our in-row size, data set size, and everything. So we have an index now. So the data is indexed, and we're just going to pull off the first set of index and the end of the index for our data. And we can run all of this in one shot. We'll go into code, and we'll run selected lines. And so now we have our data in here. We have our training set and our testing set. That's what we wanted to get to. So once we've formatted all the data, then we get to the next real easy step, which is a single line to bring in our random forest. So let's go ahead and we'll use the variable RF, standing for random forest, and we're going to assign, if you remember correctly, we brought in our library random. If you wonder why I go up here all the time, it's because I'll forget which letters are capitalized in some of these because I switch between packages so much. But it's random with a capital F for forest, random forest. So the RF is going to equal random forest. And of course, we start by telling it which column we're trying to predict. And of course, you can always go down here and double check. We're running this on the quality. There we go, quality. And we're using just that column all the way to the end. And then we've added, our team in the back has gone in and played with this a little bit, and we'll go a little bit over what they did. But I'm going to put in the values that they have set for the different options in the random forest. Before I do that, it would help if I tell it what data to use. Data is going to equal our training set. And then we have the variables that they put together. And let's just talk a little bit about what these different variables mean. So, mtry and ntree. These are some of the variables you play with the random forest. The mtry, not so much. When they first put it out, I think mtry was very common. 4 is a good value. I can't remember what the default is, but it's probably 3, 4, or 5 or something like that, depending. I think it depends on how many features you have going in there. So you could even just leave this as a default without too much troubles. The in tree, this is where it gets important, and I'm going to make this 2001. One of the suggestions is to always make this odd, like a tiebreaker, just in case. The default is like 500 or 501. And then finally we have importance equals true. I can't remember what it defaults to, but generally you want to set the importance equals to true. It actually looks at the correlation between the different features to make sure that there is some kind of correlation as it's doing its calculations. So our one line of code is going to assign our random forest and go ahead and train our random forest all in one execution. So this whole thing has been centered around getting to RF set to the random forest. And let's go ahead and execute this variable, or this line of code. And you'll see it takes a little bit down here to execute as it goes through and sets it up. And you'll see it probably takes a minute or so to execute the code, depending on the size of the data and how good your machine is. And then with all of our data, we can start looking at the answers. We'll just do RF, and we'll execute that. And you'll see that the random forest does a nice job. You can see right here it has our data equals training. It basically goes over everything we talked about. And you come down here and it has a confusion matrix, which is nice. We always like our confusion matrix when we're talking to our shareholders and explaining what the data comes out with and how it trains. And we can go ahead and plot our RF. Let's see what that looks like. And as the number of forests grows, remember we set it to 2001 forest, you can also see how the error comes in, how the different error on the different variables. This is kind of a nice graph that gives you an idea. It might help you adjust whether you really want to do 2,000 different forests. You might actually truncate this off at around maybe 800, because you notice the lines kind of continue on. Again, this is just still on the plot. And of course the next step is we need to go ahead and predict. Remember we split our data into two groups. So let's go ahead and get a result. We'll call it result, and we'll assign this one. There we go. We'll set this to a data frame. There we go, there's our data frame. And then, let's call this, we have our test quality, because that's what we're setting up on our test group with the quality on there. And then we want to have a predict, nice little keyword there to go ahead and run our random forest. And then we tell it that we're going to predict using our RF, our random forest, our testing group. 1 to 11 is what we're using. Type equals response. So let's go ahead and execute it. That's a mouthful on there. Somewhere I left out a comma in there, so it gave me an error. But you can see right here, we've set in there, now we have a result. And just real quick, we could do the head of the result, comma 5, and just take a look at the first 5 lines. And you'll see we have the actual value and what we predicted over here. And we could also just do all of the result and just see what that looks like. Oops. And print that out. And so it has all the different data we're going through on there. And finally, let's just go ahead and plot. There we go. We'll put plot up here, plot. And let's plot the result and just see what that looks like. Maybe not the best one to show to the shareholders, but it does give you an idea. On the left, on the y-axis, you'll see that it predicted 8. And this tells you that a lot of the 8 and the 8 scale was probably gave us about 50% came up there at 8. Really, maybe 50% it didn't guess right, but it did come up there and say that it was at least a 4, 5, or 6, even where it was considered an 8, and so on. You can see these different blocks coming in, so that if you line up the 3 with the 3, 4 with the 4, and you kind of cross-index them, a heat map would probably do better. But for this example, we'll just do a quick plot of the data as far as how it works. And you can again see the results that we predicted over here, and you can look those over. Of course, back in the wine cellar, we're talking to our vineyard owner. And if you remember from before, we looked at this chart right here. The error rate is 29.05%. Therefore, our accuracy is 70.95%. If you're doing a vineyard, that's probably pretty good accuracy. And always check your domain when you're sharing this stuff, because if you're doing something that's life or death, maybe 70% accuracy might not be so good. But if you're looking at where you're going to distribute the bottles to for the wine and who's going to drink it, 70% accuracy is pretty good for that. That's probably a lot better than having no accuracy whatsoever and not even knowing what wine's going out to who. So we have automated the process of predicting the quality of wine. I myself prefer to predict it by sampling it. That's great, thank you. I'd like to visit this guy and sample his wine and find out just how good his different vineyards are. So the key takeaways today. What is a random forest? So we discussed the random forest. It can be used for both classification and regression. We discussed how the random forest works, where we have the 3 different trees, where he's asking his help with his school, and then based on the answers of those 3 and who came up in agreement wins. So mathematics is what they came up with. And then we had some applications of random forest, which covers pretty much any of our data science that's out there right now. And then we talked about training the random forest. You saw how easy it was. We created our RF variable and we assigned it the random forest and trained it all in one line of script. So it was very quick and easy. We discussed a little bit with the mtry and a little bit of the ntree to know how many trees to use for this. And finally, we did the predicting quality of wine using R. So we had a final prediction on there that was about 70% accurate. Again, thank you for joining us today. For more information, visit www.simplilearn.com. Feel free to add comments in the YouTube video below. We'll try to answer any questions you have, or if you have a request for data. Again, thank you for joining us today, and happy learning.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel, and click here to watch similar videos. To nerd up and get certified, click here.